Hi, today I'm just going to give you a small update on Classful and Classless routing and also CIDR and VLSM in case you have forgotten. This is something about the IP addresses, and when we look back, we will see that in the beginning we divided the IP addresses into different classes. This is called Classful networking addressing, where we have class A, B, C, and we have class D, which is multiclass addresses, and class E, which are reserved. We will see that class A is when the IP address in the first byte begins with 0 or up to 127. Then it is a class A address. Class B is where it starts with 128 up to 191 in the first byte of the IP address. Class C is where it starts with 192 up to 223 in the first byte, and multiclass addresses go from 224 to 239, and the reserved ones from 240 to 255. Of course, these are all IP version 4 addresses that we are talking about with the different classes. The difference of class A, B, and C are only the size of the networks, because class A has a default and standard and fixed subnet mask of 255.0.0.0 or /8, which means that we use the first byte for the network, the rest of the IP address is for hosts. So we have few networks but a bunch of hosts, a very large number of hosts in each of them. Class B is the middle one, where we have a subnet mask 255.255.0.0 or /16, which means that the two first bytes are for the network and the two last are for the host. Class C, we have the three first bytes for the network and only the last one for the host. So the mask for class B is 255.255.255.0 or /24. So only the size are the difference here between class A, B, and C. The reason, or when we have routing protocols and they are classful, they don't really notice or know anything about the subnet mask. So it will, even though I send out an update here telling, okay, I have a network called 172.16.1.0 to router 2, router 2 will then not really know the subnet mask, and it will just see it as, okay, this starts with 172. So this is a class B. And then it will send out update of 172.16.0.0. So it will automatically just change it to the classful boundary and the classful subnet mask. And we'll only know about that since it is a classful routing protocol. The bad thing about this, and the reason why we do not use classful addressing anymore, is of course that we waste a lot of IP addresses. 50% of all IP addresses in this case would be class A addresses, and we will have quite a substantial 12.5% of unused addresses also. And we know, everyone, that we have a problem with not enough IP version 4 addresses. So this is old way of doing it. We will not do this anymore. So today we are using something called CIDR, Classless Inter-Domain Routing, which means that we basically don't think about the different classes anymore. We look at the subnet mask instead. And the subnet mask will then tell us when we look at an IP address, which part is the networking part and which one is the host part. So we stop thinking about whether it is a class A, B, or C address, and we just look at the IP address and we look at the subnet mask. With CIDR, we can actually we can do subnetting. We have seen that and we have done a lot of exercises with that, but we can also do route summarization or supernetting, where we add networks. Instead of dividing them into smaller parts, we will sum them up to one large sum instead of smaller networks. So in this case here, instead of having 1, 2, 3, 4 different entries in our routing table, we can sum them up to 1 instead. So here, these 4 networks are summed up to 192.168.0.0/20, which will then be the summarized root subnet mask. And this is something that we would like to have because the efficiency of the routing process will also be looking at how large is our routing table. The smaller the routing table, the more efficient the routing process will be. So we always would like to summarize the route to keep the entries in the routing table as few as possible. So here, when we have a static route, instead of having 1, 2, 3, 4, 5, 6 static routes, well then I can sum them up here in router 2 and make a route summary instead of having 6 routing entries. The whole idea of summing, or the only way when we can sum our routes is of course when they are continuous, so that now here is 172, 16, 17, 18, 19, 20, 21. When we have this set up, well then we can sum them. If I had 192, 168 something in the middle of the here, that one of course I will not be able to sum. So only continuous routes I can sum up. When we have routing protocols that are classless, well then they will understand subnetting and they will understand the subnet mask. So here it will send an update on our subnet masks instead. With the subnet mask will be sent together with the network. So it will be able to see the different subnet, and it can also summarize networks and it can subnet networks. And of course, it is something that we will always use. In the earlier days, when we subnetted, we would have to have the same fixed subnet masks on all our interfaces. Today, we can also subnet a subnet, and that is called VLSM, Variable Length Subnet Masking. So that means that we can take a subnet and we can subnet it again and again until at least we have 2 bits left for the host of the IP. So VLSM variable length subnet mask means that we can subnet a subnet. And an example here is that we have a 10.0.0.0/8, which we start by subnetting and borrow 8 bits, so we get a /16, and then we can take one of these subnet and again borrow 8 more bits, so we have a /24. Each time here we will create 256 new subnets. And again, we could take this network and subnet that again and borrow 6 bits, for instance, or whatever, how much we needed. So we can continue to subnet a subnet. The process, the opposite process where we summarize network is where we want to, instead of sending different networks updates, we will like to summarize it so we can send out just one update instead. Many of our routing protocols that support this will automatically try to auto-summarize. We can choose that, or we can take it away and disable it if we don't want to do it. But the whole idea of calculating and how to find a summary route is that you take, first of all, you need to have all your networks to be continuous, like here, 20, 21, 22, 23. All starting with 172 in the beginning. So what we do to summarize these networks is to set them up in binary and then count the mix, the matching bits of the far left part of the IP address. So we start from the beginning and count how many bits do we have in common here. Well, we have the first 14 bits in common. That means that we can summarize it with a /14 subnet mask. And to find the network address of the summarized network, well then we keep our 14 first bits, which are now the networking bits, and then we set zeros in the host portion of the IP address, and then we find the address of the new summarized network. So in this case, we can summarize these 4 networks into 172.20.0.0/14. So you always have to make the IP addresses binary and count the matching bits to find out if it's able to summarize the routes. Then again, another example here, we have 172.16.1, 172.16.2, 172.16.3. Then again, we just put them into binaries and count the matching bits. And in this case, we have 22 matching bits, so we can make a /22 subnet mask of our summarized routes. So instead of advertising these 3 networks, we can advertise only 1 network instead, which is the summarized route. Yeah, and that was it. Thank you.